So this lesson is about the quadratic formula and the discriminant. So first let's review quickly the quadratic formula. So if you have an equation that looks like this, ax squared plus bx plus c equals 0, then the solutions to this equation are given by this formula, and I like to sing this formula to the tune of Happy Birthday. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's how I memorized that formula. Anyway, so let's look at some examples. So we'll start by solving x squared minus 2x minus 6 is equal to 0. Again, we're supposed to use the quadratic formula. So first of all, I want to notice that a is 1, b is negative 2, and c is negative 6. I always write the formula down, but you don't have to. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I start plugging the numbers in. So x equals negative, well, b is negative 2, so parentheses around negative 2, plus or minus square root of, well, b again is negative 2, so negative 2 parentheses squared, minus 4ac, so minus 4 times a was 1, times c, which is negative 6, all over 2a, so 2 times parentheses 1. Now it's a matter of simplifying. I would recommend starting by simplifying what's underneath the square root. So first we're going to square the negative 2, it's going to be 4. And then we're going to do negative 4 times 1 times negative 6, negative times negative positive, so 4 plus 24, so it's going to be positive 2 plus or minus the square root of 28 all over 2. Now we would want to simplify the square root of 28, or at least partially. So again, I'm going to do a little thought bubble here to remind you about the simplifying of radicals. So I'm going to take the 28 and I'm going to factor it. 28 is 2 times 14. 14 is 2 times 7. And so 28 is really 2 squared times 7. And so what I have here is x equals 2 plus or minus the square root of 2 squared times 7 all over 2. Now the reason why this is helpful is because I can partially simplify the square root. Square root of 2 squared is just 2, and then square root of 7, well, I can't do anything to that. So it's 2 plus or minus 2 square root 7 all over 2. Now, it's all over 2, meaning 2 is the common denominator. Remember, terms are separated by plus signs and minus signs, where plus or minus, that's one big sign. So each numerator term is divided by 2. So I have 2 over 2, and then plus or minus 2 square root 7 over 2. And that allows me to then cancel in this term, 2 over 2 is just 1. And in this term, the 2 over 2 cancels, so I'm just left with root 7. So I end up with x equals 1 plus or minus the square root of 7. Now, of course, don't forget that it really means x equals 1 plus square root 7, and also x equals 1 minus square root 7. But it is acceptable to leave the answer that way. All right, so now we're going to solve this equation, again, using the quadratic formula. First thing I notice is this does not look anything like the correct form. It should be ax squared plus bx plus c equals 0. Now, I'm also tempted, if it says x plus 2 squared equals, if this was just a number, I could just square root both sides, of course, remembering plus or minus. But the fact that there's x's on the other side means I can't do that. So the first thing I want to do is rewrite this so it becomes ax squared plus bx plus c equals 0. So the first thing to do is to square out this binomial. So it's going to be x squared plus 2 times x times 2, and then plus 2 squared. And of course on the other side I'm just going to have x plus 10 minus x squared. I'll worry about that in a second. So the left hand side becomes x squared plus 2 times x times 2 is 4x, and then 2 squared is 4, so plus 4 equals x plus 10 minus x squared. Now, it doesn't really matter which side becomes 0, but I like to have the x squared positive if possible. It's just, a little more convenient. So I'm going to add x squared to both sides, and then I'm going to subtract 1x, and I'm going to subtract 10. So I'm going to get 2x squared, and then plus 3x, and then minus 6 is equal to 0. Now it looks like it's in the right form. Ax squared plus bx plus c equals 0. So I can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I plug the numbers in. X equals negative, well, b was 3, so negative of 3 plus or minus the square root of 3 quantity squared minus 4. A is 2. C is negative 6. And then extend that square root symbol so it covers it all over 2 times 2. All right, so once again, the best thing to do is to figure out what's underneath the square root. That's the most complicated stuff first. So 3 squared is 9. Negative 4 times 2 is negative 8. And then negative 8 times negative 6 is positive 48. So 9 plus 48 ends up being 57. So I end up with negative 3 plus or minus square root 57 all over 4. Now I would like to simplify the square root 57 as much as possible, but I can't. There's nothing I can do to factor 57 into things that end up involving squares that can ultimately cancel with square roots. So you can just leave the answer this way. Now if you don't like leaving it that way, you can also do the following. You could say x equals negative 3/4 plus or minus square root 57 also over 4. That illustrates that 4 is the common denominator for two different terms, but it is okay to write it this way. So now let's talk about the discriminant. So this is the quadratic formula again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The stuff underneath the square root, not including the square root, but just underneath it, is called the discriminant. Now, sometimes we use the letter delta. It looks like a triangle. It's a capital letter delta from Greek. And of course, in this case, it's b squared minus 4ac. You could also use d for discriminant or just write the word discriminant, but I'm going to stick with what the textbook does and what's pretty common. The delta equals b squared minus 4ac. Now, what is the point of the discriminant? Well, so if you ever want to know how many solutions and what type of solutions you have, but not actually what those solutions are, then the discriminant comes in handy. And the reason is, if the discriminant is positive or greater than 0, then you're taking the square root of a positive number, because that's where the discriminant goes, and you know how to take the square root of a positive number. That works perfectly okay. You get real numbers, and therefore when you put it all together, you have negative b plus or minus square root of whatever positive number it is, divided by 2a all over 2a. So there's plus or minus gives you 2 real solutions. So there are 2 real solutions. Real meaning real numbers. Now, if the discriminant is equal to 0, well, then you're trying to take the square root of 0. When you take the square root of 0, it's just 0. Well, plus or minus 0, plus 0 minus 0, those are the same. It doesn't make any difference. So you still get a solution. It's just going to be x equals negative b over 2a because the plus or minus 0 doesn't do anything. So if the discriminant is equal to 0, there is one real solution. Now, if the discriminant is less than 0, in other words, if the discriminant is negative, then you're going to have to take the square root of a negative number. Now, some of you have learned about imaginary numbers. In SL, you do not have to worry about imaginary numbers. We're going to stick to just real numbers. So you're trying to take the square root of a negative number. We're just going to say you can't do that. Therefore, because you can't actually do the calculation, we say there are no real solutions. So again, if all we cared about was how many solutions and what type, then we wouldn't actually have to use the entire quadratic formula. We could stick to the discriminant, which is the stuff underneath the square root. And if the discriminant is positive, you get 2 real solutions. If the discriminant is equal to 0, you get 1 real solution. If the discriminant is negative, there are no real solutions. Okay, so here we are asked to determine the nature of the roots of these two equations. Roots is just another word for solutions. So, and when it says the nature of, it means you don't have to figure out what they are, just what type are there, how many are there. So it's a discriminant question because I didn't actually want to know what the roots or the solutions were, just what type they were. So the discriminant delta is b squared minus 4ac. So in this case, b is negative 2, so it's negative 2 quantity squared minus 4 times a is 2, and then times c is 3. Well, when I square that negative 2, I get positive 4. And then when I multiply 4 times 2 times 3, 8 times 3 is 24. So it's minus 24. So this is negative 20. Well, that's a negative number. And when you get a discriminant that's a negative number, that means that there are no solutions. Okay, here's another one. I want to again determine the nature of the roots of this equation. The first thing I notice, it's not written in the correct order. It has to be ax squared plus bx plus c equals 0, not this. So I need to move some stuff around. I like to keep the a positive. It's not necessary, but I like to keep it positive anyway. So I'm going to move these two to the left-hand side. So 3x squared minus 4x minus 2 equals 0. And again, it's about the nature of the roots or the type of the roots and how many. So it's just a discriminant question. So delta equals b squared minus 4ac. b here is negative 4. So negative 4 quantity squared minus 4 times a is 3 times c is negative 2. All right, so negative 4 quantity squared is positive 16. And then negative 4 times 3 times negative 2. Negative 10 is going to be positive. 4 times 3 is 12, 24. So plus 24, which is 40. That's a positive number. That means that there are 2 real solutions. Let's look at some more examples. So here we're asked to find the values of m so that x squared minus 2x plus m equals 0 has 2 distinct real solutions. The word distinct here means they are different. So it just in this case means 2 real solutions or 2 real roots in this case. All right, so there's an m. There's this funny number here. I just don't know what it is, but it's not about what the solutions are. It's about what type and how many. So because it's about what type and how many, it's a discriminant question. So delta is b squared minus 4ac. And in this case, b is negative 2. So negative 2 quantity squared minus 4, and then a was 1, and then c is m. Now, if I want 2 distinct real roots, ultimately, this has to be greater than 0. So I'm going to set it greater than 0. That's what I'm looking for. And then I just need to solve this. So of course, when I square the negative 2, I get positive 4. And then minus 4 times 1 times m is minus 4m is greater than 0. Now I'm going to subtract this 4 from both sides and get negative 4m is greater than negative 4, and then I'm going to divide both sides by negative 4, but wait a minute, when it's an inequality, whenever I divide or multiply by a negative number, the inequality flip-flops, it changes its direction, so m is going to now be less than positive 1. Now the question said find the values of m so that this would happen. Well, this means a lot of m values, anything less than 1 will work, so we've now answered the question. If m is less than 1, then this equation has 2 distinct real roots. All right, find the value of n so that nx squared plus 8x plus 8 equals 0 has a repeated root. A repeated root actually means it's the same root twice. Well, if it's the same root twice, we saw that earlier. If we had x equals 2 and then another x equals 2, we just listed it once. So it's really saying that there's only one root. or one solution. In fact, it used a, meaning singular. So there's only one solution. So again, it's not about what the solution is, it's about the type and how many. So it's a discriminant question. So delta equals b squared minus 4ac. And in this case, b is 8. So 8 squared minus 4, and then a is n. And then c is 8. And if I want to get a repeated root, I want the discriminant to be equal to 0. That gives me one solution. That's what we need. So now I just need to solve this equation. Luckily, it's an equal, so I don't have to worry about the flipping of the inequality. It's just an equal sign. So I square the 8, and I get 64 minus 4 times 8 is going to be 32, so minus 32n equals 0. I can subtract 64 from both sides, so negative 32n equals negative 64, and I can divide by negative 32, and I don't have to worry about switching inequalities, so n is equal to 2. So the value n equals 2 makes this equation have one root, or a repeated root. I never cared what that root was, I just need to know what number over here would make this have a single repeated root. And that is the end of the lesson.